Good afternoon, everyone, and thank you for attending our Navigating UL and CSA Standards for Flexible Heaters Used in Industrial Equipment webinar. My name is Ryan Wood, the Content Marketing Manager here at Epec. Before we get started, I just want to let you all know that you'll be muted during the presentation. If you have any questions as we move along, please enter them into the questions panel, which is located in the webinar control panel, and we'll try to get to all of them at the end of the presentation. If we don't have time to go through all your questions, we'll be sure to reply to you by email. Also, we'll be recording this webinar and posting both the recording and the slides on our website and YouTube channel. Our presenter today is Stephen Goodman, our User Interface and Cable Assembly Product Manager. Stephen is a mechanical engineer with a Bachelor of Science and MBA from Northeastern. As the User Interface and Cable Assembly Product Manager here at Epec, Stephen works closely with customers to provide solutions to specific problems during design consultation and, where needed, helps with the creation of specific designs. So without further ado, I'll pass on over to Stephen.
Thank you, Ryan. Good afternoon, everyone. Again, my name's Steve Goodman. I'm one of the product managers here with Epec. Today, we'll be talking about our UL and CSA certified flexible heater products, many of which are used in various types of industrial equipment. So our agenda. First, we'll be talking a bit about some of the capabilities and manufacturing techniques used to create these products. Next, we'll be discussing the specific regulatory requirements for these flexible heaters, followed by a deep dive into some of the UL and CSA standards. Next, we'll be talking a bit about how our design changes will have a potential impact on your certification. Lastly, we'll be going through ways to customize your heater for your new project. Finally, we'll have a brief Q&A session at the end of this. So, a bit more about our capabilities here at Epec. Specific to flexible heaters, we manufacture various types of high reliability flexible heaters. These devices are fixed resistance heating elements that are driven by Ohm's law, which is a relationship between voltage, resistance, current, and therefore power. In terms of units, we typically refer to the power of these in watts, or even a watt density, which is watts per square inch. Based on your power requirements or voltage input requirements, we customize every heater for your given application. The footprint of the heater can be changed, the shape can be complex, and overall, the actual length of the element within the heater and its cross-section is what drives the overall resistance value of the heater and therefore its power rating. These products are very similar to flexible circuits, where with most flex circuits, the conductive material is copper. Copper is wildly conductive. Our heating elements use various different alloys that are higher resistance, and therefore, when power is passed through them, they generate heat. Each heater is completely customized, not only with its shape and power rating, but with the addition of different types of adhesives, foam backings. We default to using 3M brand PSAs, or pressure sensitive adhesive, for all of our products. 3M 467 and 3M 468 are our most common PSAs that we pair with all of our heaters. Additionally, you need to get power to these somehow. Most heaters have wires terminated directly to the heater pads, and those wires can be various off-the-shelf UL spec wires to custom wires, any combination of color, gauge size, and overall length. Another key facet here is how to properly strain relief the wires. This is a point of failure with some designs. Every design we create has a detailed DFM, design for manufacturability, that's performed. in which we may make recommendations to the wire attachment method and any additional strain relief that would be necessary. Again, how our flexible heaters work is you pass electrical current through the traces and heat is generated. We use these all over in our daily lives, whether it's toasting your bagel in the morning or us here in the Northeast trying to defrost our rear windshield. These types of devices are everywhere. Our specific devices that we make are primarily the polyimide and silicone type. This slide shows several examples of these with our silicone encapsulated heaters on the left and our polyimide design type on the right. As shown, these can be completely customized. Overall length, width, even thickness can be customized to your specific application. In our experience, they both have similar price points and they both operate similarly. However, the silicone variety is both better at operating at higher temperatures and also has a bit better temperature distribution and uniformity, eliminating any potential hot spots. Depending on what you're trying to do, polyimide may work best for you if the overall thickness is a concern of yours. The one area to note, though, is the wire attachment area. In some of these photos here, you can see there is a small raised portion to strain relieve that. That is usually the thickest area of these flexible heater products. There's a lot of ways we help our customers in this product line. One of the primary ways is by partnering with one of our stocking distributors. That's Omega. They have numerous common sizes of both silicone and polyimide flexible heaters readily available in stock. These are great if you need onesie twosie order and you're not really sure the exact wattage or power requirements you need, but you want to throw something on the bench and get testing. We then support with a higher volume production build where we can further customize whatever your heater requirements are. We don't really need a lot of information to start the process and get you and your team a quote, but we do need the rough size and the footprint of the heater. We'll need to know how you're energizing it, what the wire gauge and length would be, and lastly, how you want the heater to perform. Since these are fixed resistance heaters, if you know the open circuit resistance of the heater, that is what we need. But then we can do further analysis to make sure that it won't operate too hot with the supply voltage. For that fixed resistance, we typically guarantee about plus or minus 10% of whatever nominal resistance value you're targeting. Additionally, if your application requires some kind of UL or CSA testing, we have numerous existing stack-ups and designs that have the existing UL and CSA mark, meaning you can avoid tens or hundreds of thousands of dollars and weeks or months of timeline if you do need a UL mark. The challenge there is you are limited with some of the cross sections and some of the material thicknesses. If you're willing to work with us, there should be a solution that we can offer you if you do need a UL mark. Lastly, we have a complete suite of off-the-shelf components and protection devices like thermostats, thermal fuses, thermistors, thermocouples, etc., that we can attach directly to the heater or in series with the cable that's attached to the heater. Next, we'll dive into some of the regulatory requirements for flexible heaters. So a good question that our customers ask is, how do we know if their given heater needs NRTL, Nationally Recognized Test Lab certification? There's several ways that you may be notified of this. The most obvious is that your end customer simply requires it and tells you. There's many situations where they themselves don't necessarily know, And it may actually be driven by some higher up entity like OSHA or the actual government of wherever you're trying to sell this. Ultimately, whatever drawing that Epec is using to create this documentation and create our design, there should be an explicit UL or CSA requirement noted with a specific section. And if not, sometimes the part marking on the drawing just simply has a UL mark like the one here on our screen. If that's shown on your drawing, that part needs the UL testing. There's also situations where UL may not necessarily be required, but for whatever reason or the application, your management or your customer's management may want to add additional product safety risk and go through the motions to achieve or mark the parts with the applicable UL or CSA standard. A bit more about what these third parties, these NRTLs, do during the review. It's a very complex and extensive deep dive into the design, the bill of materials, and any potential source of risk. But one of the most important things that they'll do is actually take samples, completely dissect them, and document the results. Here's a photo of a silicone heater with an inline thermostat, a silicone patch, and a standard service cord. During their review, they will completely take apart the heater, analyze it, and document their results. They may perform flammability testing on the various components here for any items that are not listed. What that means is some of these items, like the thermostat, for example, and the wire, and the silicone film, all have independent UL testing done on their own before they get to be assembled into a fully functional heater. It's important when you are looking at a new design, and it's important when a company like Epec partners with you, that we understand whether or not you need UL or CSA testing early in the project. That's because when we're selecting components, we default to using listed or already UL or CSA approved items in the bill of materials. This helps fast track any potential third-party agency reviews and helps get any additional UL testing and markings done faster for less total program cost. During the actual process of building these heaters, there's a lot of input materials, there's various labor steps, and ultimately you're arriving at a finished product. Epec, as a hybrid manufacturer, we have the ability to manufacture and assemble heaters both here at our corporate headquarters, where I'm based in New Bedford, Massachusetts, and also at our production facilities across Southeast Asia. Depending on the specifics of the design, how it's being built, and what the UL or CSA requirements are, an initial factory assessment, or IFA, is required to properly mark this widget with the UL or CSA marking. What that involves is a third party coming out and actually doing a site audit of the manufacturing location where the heaters are built. This is inherent in the process and something that we absolutely can and do support. When all is said and done, hopefully the UL testing and CSA testing is passed. This is the resultant, a certificate of compliance to whatever the UL or CSA listing is. This document here is what you and your team may need to show complete compliance, in addition to the part marking and logos printed on the widget that you're making. This document includes a specific dated UL file number. It also has the manufacturer's number, usually begins with E and then 6 digits. These certificates are issued to a specific manufacturing entity and are only given out after the complete evaluation of a suite of samples. Next, we'll be doing a deep dive into both UL and CSA actual requirements. So focusing on industrial equipment, there's a lot of places that these types of high reliability, low profile, flexible heaters are used. Whether you're trying to warm a battery to improve its efficiency and capacity, or you're trying to warm an otherwise viscous fluid like hydraulic oil or motor oil, or you have an oil filter that you're trying to warm to make sure oil flows through properly. Many of these applications already use these types of low profile flexible heater devices. Various types of industrial equipment, lab equipment, and other types of test and measurement devices use these types of heaters. Another common situation for Epec to build custom heaters for is actually a resistive load bank, where you're not necessarily trying to warm something, but you're trying to dissipate energy that's created for any number of reasons. Certain rotating systems may have braking systems that need to dissipate electrical energy in the form of heat. These high reliability, low profile, flexible heaters can be customized to whatever fixed resistance value and be used as a resistive load bank instead of some of the other options that exist out there. Another common application we see is adhering the flexible heater directly to an aluminum plate. We can make those custom aluminum plates, whether it's from machined aluminum, hogged out, or sheet aluminum. We can completely customize those plates, laminate the heater directly to them, and build that for you, and even have the UL as a part of that entire assembly. Ultimately, whatever UL and CSA certifications that you need will be driven by the end product and application that the heater would go into. So we're going to talk a bit about the actual product safety tests that our flexible heaters go through on their way to achieving a UL or CSA approval. The first is a flammability test. That's one of the most important. The goal there is that we're using materials that will self-extinguish and will not propagate a flame. Many of these are off-the-shelf materials or compounds that we've been using. So we already have the test data that shows that it already has various favorable flame ratings. The next is a suite of temperature tests where we're energizing the heater and making sure that it achieves its normal operation temperatures and doesn't create a hazard to the user or the equipment. Next is a dielectric strength test. Basically, that there's no risk that under a high voltage situation that the heater will burn out or short circuit. Other electrical tests include a leakage current test, which helps detect an inadvertent flow of current outside the heater, which then could be a safety hazard or otherwise damage equipment. Endurance tests are performed to go verify that the heater will perform reliably over long periods of time. This can take several weeks and involves various temperature cycling and energizing the heater. The heater must operate throughout the entire time. Similar to some of the mill standard and RTCA DO160 tests, humidity testing is just as important to make sure that the heater does not break down after exposure to elevated humidity levels and low temperature conditions. The heater is then bent and manipulated to make sure that the heater still operates and doesn't create a hazard. Next, we'll be talking a bit about UL and specifically UL 499. UL, also known as Recognized Laboratories, is a third-party global organization that set out to develop the standards and helps perform product safety testing. Generally speaking, we work with other third parties to actually do the testing to the requirements of UL. Being a product safety organization, their mission objective is to help verify that electrical products don't create hazard to the user or other equipment, nor do they create fire or other safety risks. UL 499 is the specific safety standard that we test to and have our heaters qualified to. There are other UL specs, and given your application and customer and what you're trying to do, there's others that may apply for whatever your design objectives are. As I mentioned before, there's several tests and performance criteria that UL 499 covers. The first is the electrical insulation and dielectric strength of the heater. Next would be the temperature limits and any overheating protection circuits that are built in. Next is an evaluation of the mechanical design and its durability. Another major component of the UL 499 testing is to make sure that the device is properly grounded and any potential electrical leakage is mitigated through various design measures. Lastly, and most importantly, the materials that the heater is built with must self-extinguish when exposed to a flame. Once UL 499 testing is completed, each heater is then allowed to be permanently marked with the manufacturer's identification number. That's that E 6-digit number I mentioned previously. The heater must be marked with its electrical ratings, not just the voltage, but whether it's AC or DC. UL will reject the parts if you do not specify an AC or DC voltage on the part marking. There also needs to be a power or wattage. Obviously, the UL recognition comes with that mark, but you cannot place that mark until you've completed all these tests. Some products may have a warning or other installation instructions that prohibit certain aspects of the design. Those would then be permanently marked on the heater as well. A large family of our heaters carries the KSOT8 rating within UL 499. CSA, also known as Canadian Standards Association, is very similar to UL, but instead of being a US focused entity, has a focus on Canadian safety standards. Again, they're an independent third-party organization that develops the standards. CSA is very similar to UL, and there is tremendous overlap. In our experience, if you have an existing UL rating, it's highly likely you can achieve a similar CSA rating. You cannot mark that part, though, with the applicable CSA rating until you've gone through the said tests. Focusing on Canadian product safety markets, the list here of product safety tests is very similar to what I covered for UL. The electrical insulation and dielectric strength, the temperature limits and overheating protection, mechanical durability, leakage current, and flame ratings are all the exact same tests you're doing with UL. As you can see with Epec's capabilities, our existing line of heaters is certified to both UL 499 and CSA C22.2 because all these tests are effectively the same. Similar to the UL marking, to mark a heater with a CSA marking, we must have that same manufacturer's identification number, electrical ratings, again specifying the AC or DC voltage, and any additional warnings or installation concerns. And what you may notice in a lot of these products is that the UL and CSA markings are frequently placed together in similar locations on the custom heater. Depending on the exact requirements and applications, a majority of our custom heater products go through 100% high pot testing. Quite literally, UL will dictate to the manufacturer, to Epec, that 100% of production of the products covered by this report shall be subjected to a routine production line dielectric withstand test, also known as high pot. That test needs to be completed on a fully assembled, fully connectorized heater. And there's various test conditions, but usually it's 1,000 volts or 1,200 volts. This is a dangerous test. This is not something to do without the proper experience, equipment, and safeguards to make sure that the user, the operator, and other adjacent equipment doesn't inadvertently become energized or become the path to ground. Next, we'll be talking a bit about how design changes have an impact or no impact there on certification. So earlier in the webinar, I did mention how we strive to use listed off-the-shelf components. These can be any number of devices, whether it's a NEMA plug, like one shown here with the ETL mark, whether it's an off-the-shelf thermal fuse or thermistor, maybe if it's a surface-mounted IC or other device. All of these devices, if they have an existing listed characterization, they can be added to the build with relatively low risk. Still, adding these does change the form, fit, function of a heater, and therefore must go through some additional review by these third parties. This example here is a silicone heater with a very simple wire coming off the end here. These three donut-shaped heaters that range from a 2-watt heater, 10-watt heater, and 20-watt heater, all at 5 volts DC. These all can be classified under the same UL or CSA certification because they're effectively the same heater. The only difference is the etched foil pattern. The trace of the heating element is just different between the three. All three use the exact same bill of materials, all use the exact same 18-gauge wire, all three use the exact same 3M PSA that's on the rear of the heater. As long as the heating element and its open circuit resistance is the only thing that changes, these three can all fall within the same UL certification, as long as that's communicated early in the process, and that's the way these third-party test agencies will go forward and submit the certification. As I said, changing the heating element does not necessarily change the UL or CSA. And this is true for both our etched foil designs as well as our wire wound designs. Both of these use existing heating element materials that are listed, and all you're doing is just changing their overall length and effective cross-section. According to Ohm's law, as long as all we're changing is the fixed resistance, these designs can all fall within the same UL specification. This is accomplished because of our manufacturing techniques. We etch our own heating element foils, and we use our own calendared out sheet silicone film and completely customize it to shape. And by changing the footprint of using existing listed materials, you can achieve a completely different shape while their thickness and cross-section may be the same. The different shape and then therefore different wattage or fixed resistance can all fall within that same UL or CSA listing. A lot of our customers come to us and ask us, what kind of cost and timeline impacts would it take to achieve a UL or CSA listing? My favorite answer is it depends, but that's the truth. If we can use one of our existing UL approved stack ups and you're not adding additional connectors or components to it, there's a high likelihood that we don't need to go through the additional third-party testing. But if you do have a custom design with a different type of cable that we have existing and the addition of thermostats and other unique components, there may be a full UL and CSA suite of testing that's required. Additionally, if you're looking to qualify the heater to a UL or CSA spec above and beyond what we already have certifications for, then we would be starting from scratch in this regard. That timeline can be roughly 3 to 5 months and be $20,000 to even $200,000. It really depends on the number of parts you're trying to test, the types of testing we have to do, the cost to actually make samples that we're going to go ahead and destroy and analyze during testing, and then followed through with the eventual site audit that's necessary to properly part mark these heaters. As I said, if you have an existing UL and you're adjusting one component and that has a listing already, the recertification cost and timeline is very minor in the grand scheme of things. Next, we'll be talking a bit more about how to customize your heater for a new project. So one of the very first steps, as I alluded to earlier, is it needs to be determined whether or not a UL or CSA mark is required. And if so, if there's a specific section that it must adhere to. Once that is addressed, the rest of these questions here can be answered quite easily. We always encourage our customers to do thermal testing early in the process. As we mentioned, our stocking distributor, Omega, carries hundreds of different types of flexible silicone and polyimide heaters in stock that you can test to. We want to know early if there's any specialty materials involved, whether you need a low outgassing PSA or a specialty foam that has a certain thickness, or if it's an off-the-shelf connector with a 20-week lead time. These are important for us to do our evaluation, both at the initial design phase, as well as any product safety recommendations we would make. We're always looking for our customers to tell us, is there anything unique, anything special about your design or your application? The more we know about what you're trying to accomplish and what your design intent is, the better off we both are. We always recommend that our customers plan for at least one design iteration. That's R&D. We obviously try to size the heater the best we can to your application on the first shot. But in our experience and the complexities of some of the heat transfer properties, we always suggest to plan for one design iteration so you can build, test, iterate, and then move on to production. For Epec to move forward with an initial design review and a potential quote, we don't need a lot of information, but we need some. We always prefer to get a detailed drawing from our customers. That is the preferred documentation. If there's anything unique in your application, we also want to know that, whether it's a maximum allowable thickness, if you're trying to adhere the heater onto a cylinder, if there's a high stress or high bend location, share that information early and often with us in the process. We don't need a lot, but we do need something, and even just a basic sketch, some of us here call it a napkin sketch, is all we need for a first-time build to be successful. Some of our customers don't even have that, and that's okay. Get us a rough text description of what you're trying to build with an overall size, a power, a voltage, or a fixed resistance requirement, and the rough gauge and length of wires and approximately where you want them attached. And we can do the rest. For every project, we always make a drawing. That's inherent in our process. Whenever we move from a low rate initial production build to full rate production, upon receipt of a purchase order from our customers, we create a dedicated manufacturing drawing that's fully detailed with overall length tolerances, with a material stack up, a bill of materials, and a complete Ohm's law analysis to make sure that the heater you're trying to energize is not going to burn itself up. Once we have this, we will send it to you before we build any parts. This is part of our approval process and also a way for us to regurgitate the design back to you to make sure that we've properly interpreted and understood your drawings. If you do decide to move forward with Epec, we do have a flexible heater inquiry form that allows you, the customer, to capture all this information on one document. This is not a requirement, but it is a nice to have for us so we can capture all the relevant information and use that as we mature our quote and potentially our initial production run. Wrap it up with our summary here. As I've said, if you need a UL or CSA marking, this must be communicated clearly at the start of your project. If not, your costs and timeline, and even the effectiveness of your parts can be compromised or lengthened. We have existing certifications already that we can potentially use and apply to your products. This covers our polyimide and silicone heater designs. Changing the footprint or the fixed resistance value usually does not require additional certification, and it depends on several other things. But generally speaking, if all you're changing is the footprint and the bill of materials and stack up of the heater is the same, we usually do not require an additional certification to mark the part with the UL or CSA marks. We always suggest our customers use off-the-shelf components that are listed and or are UL recognized. If not, that can equate to months or thousands of dollars of additional testing that's needed to be fully compliant. And lastly, if you do need UL or CSA testing, and it's a clear requirement that we have to go through additional testing, that itself can be months or tens or hundreds of thousands of dollars to complete that. Next, I'm going to kick it over to Ryan to talk a bit about our products here at Epec.
Thank you, Stephen. While he reviews all the questions that came in, I want to briefly mention some of the additional products we offer here at Epec. For over 70 years, Epec has designed and manufactured custom-built to print electronic products. Our expertise not only lies in printed circuit boards, but in custom battery packs, overmolded and other types of cable assemblies, flexible heaters, high reliability user interfaces, and EC fans and motors. Now I'll turn it back on over to Stephen to go through some of the questions that came in.
Thank you, Ryan. First question here is, do you support Kapton flexible heaters? That is a great question. Kapton is just a brand name for polyimide. We typically do not use the brand name Kapton. It's wildly expensive, and what we have is form, fit, function equivalent, and we have a UL rating for our own house brand polyimide. So we can support it, but typically we do not. My response to this question would ultimately be, if you need brand name Kapton, I'd like to work with you and your team to understand why, but we certainly could build with it. Next question is, what happens if UL testing fails, and what's the impact on certification? So it would depend on what specifically fails. A lot of what we see is its clarifications of the design intent, or how it's assembled, or how it's grounded. So I wouldn't call those failures as much as just part of the back and forth that is inherent with bringing any UL approved heater to market. These third-party entities will go through the design and application and completely investigate every one of these situations. If there's an actual failure, that's another issue altogether. If the failure is related to a flammability test, in our experience, it may be due to sampling or a change in the flame retardant that's needed for a given material. Or if there's an electrical failure, it could be a mechanical or electrical design flaw that UL or CSA's testing has actually ferreted out. So depending on the actual issue, there's any number of actions that either Epec or our customer would need to take to remedy the situation. Next question is, do we use Intertech and SGS? Yes, we do, absolutely. And the follow-up is, if so, what do they need to quote UL certification? So if you're unfamiliar, Intertech and SGS are the actual third parties who do a lot of this testing and will actually issue the certification and do the site audits. And in our experience, they don't need a lot to quote, but they need what the spec is you're trying to adhere to. They'll need a complete set of drawings for the design, information on the application, and a complete bill of materials. If they actually go through and do the testing, they will need all that information formalized and actually a whole bunch of samples that they're going to take apart. Next question is, I didn't see any information on cartridge or thick film heaters. Do they follow the same path? So while we do support some cartridge and thick film designs, that is not, at least today, a core competency of ours. We do some of them. And yes, they absolutely would follow a similar path, almost identical path. Last question we can take here is, you mentioned that high pot is performed on 100% of production parts. Why not the other tests you mentioned? So that's a great question. The answer, at least I have, would be that UL dictates that high pot is performed on 100% of production parts because it's a screening test to make sure that there's no manufacturing defects. Whereas a lot of the other tests are are more looking at the bill of materials, the actual raw materials used. So as long as your build plan doesn't deviate in the raw materials that you're using, if you pass flammability testing day one and you're using the exact same silicone or the exact same polyimide, you should get the same results in perpetuity. However, there are manufacturing defects that occur. Could be a training issue, could be an equipment issue, but the HiPot is a great way to root out some of those. And in doing so, what you're effectively doing is you're making sure there's no live components or no way that a person or other equipment's going to get shocked or electrocuted. That is all the time we have for today. Do want to thank everybody for attending our webinar. If you have any additional questions, please send them in. Thanks again and have a great afternoon.